Hello students. So today we are not going to cover maths but application of maths, that is physics. So basically I'll cover only one topic, that is trigonometry. Application of trigonometry on physics, applied physics you can say. So some people have curly brown hair, everybody knows sine theta is equal to, we keep on saying sine theta equal to perpendicular by hypotenuse, cos theta is base by hypotenuse, tan theta is p by b. So what is its application in physics? Particularly physics in motion we very much apply these two. How do we apply? Say I throw a ball in this direction, that is where velocity comes into picture. So you throw a ball. Now I know that I threw the ball in this direction, but if I make a right angle triangle around it, and if this is theta, so, and if I complete this triangle, this is hypotenuse, this is base, and this is with say force F. Now see, this is not the way it works, but it is the way we assume. There are certain assumptions in physics. You can draw many right angle triangles. Try to understand. If you throw a ball like this, you can make a right angle like this, you can make a right angle like this. It's all up to you. It's all upon the problem. It's all upon what you want to calculate. That is most important. So for this example, you might have heard horizontal component of the force and vertical component of the force. That is where trigonometry comes into picture. And now you also must have heard of vector diagram. So if the force is this one, if the force is this, OF, force is a vector, right? Force is OF, correct? So the by magnitude the horizontal component of the force is OX. Horizontal component of the force is equals to OB. This sign says it's a vector. It's not only a value, but it has a direction. You know the difference between speed and velocity. Speed is just a number, meter per second, but velocity is a number, and at the same time it has a direction. So those quantities are called, you must have heard of scalar and vector quantities. So those quantities are called, which have direction involved in it, they are known as vector quantities. So if you split in, this is the horizontal part, and this is the vertical. You threw the ball in this direction, right? So there is a horizontal part and there is a vertical part. And now to resolve our problems, why do we consider, you may ask, why do we consider, sir, this is 90 degree, why don't we consider a right angle like this? That's a question, and it's a very good question, because our calculations, we know some formulas like v square minus u square equals to 2as, s is equal to ut plus half at square, V equal to U plus AT. Kinetic energy equals to mgh. So our equations, when we resolve equations, we have to put anything into the form of an equation, right? When we put that into an equation, we need to eventually reach somewhere, reach to a conclusion, reach to a value, calculate some value. So we have horizontal component, like you are considering frictional force. If a car is moving like this, now if a car is moving like this, say on an inclined plane, a car is moving. I don't know how to draw a car, but it's something like this, right? Something, okay. Now if a car is moving, now the car is moving in this direction now. So horizontally it's covering, actually it's horizontally it's covering this much distance, right? And vertically it's the height that is getting considered. So that is the reason we break it into horizontal and vertical and horizontal component, and that is where we apply this sin theta and cos theta. So eventually what is the component? You know, cos theta is OX by OF. So cos theta is OX, OF is force, right? OF is force, right? OF, force, cos theta equals to OX. And similarly, if you apply in sin theta is Fx by OF. See, I am doing it slowly so that you understand this. Fx, these are, see, in mathematics too, OF is you know, OF is force, F sin theta. So at any point of time you can break the force into two lines perpendicular to each other, and the direction of the force or whatever force you are applying should be between these two lines. It's not that you draw a right angle triangle here. No, your right angle triangle should surround this. If this is theta, then this is cos theta and this is sin theta. If this is theta, then this is, always remember, the base is always attached to the hypotenuse, base, and there you have to apply cos to get the base. To get the perpendicular or the vertical part, you have to apply sin theta. But if theta is given, then this becomes base. Here this is f cos theta then. So to make it simple, so this is f cos theta, so this is your f. So this means OX is what? OX is horizontal component. OB, why I have written horizontal component is OX, sorry, and that is equal to f cos theta. And this is vertical component of the force equals to OF, right? OX f cos theta, Now you may also ask that what if this theta is given? Sometimes they say, then it's very easy. Then this OX will become, say, a point M, and then this one, you complete this triangle, this one will become sin theta, f cos theta, sorry, and the vertical component, horizontal component will become, and this is equal to this, right? Anyways, this, you know, this is theta, then this is f cos theta, and this is f sin theta. Don't get confused. You will get confused. I'll show it in a different diagram. So at any point of time, see, you are walking how do you walk on surface? Do you walk like this? You push the earth in this direction? No, we don't walk like that. We push the earth in this direction, and the earth pushes us in this direction. That is the reason, action to reaction, in Newton's third law of motion. Earth pushes us in this direction. Now there are two components of that force. We don't fly. We don't fly because our gravity, our weight balances out that. But there is nothing stopping us from here. Yes, we do have if you wear very, boots with very long, how do I say, stripes. I mean, a boot with too many stripes in it, too deep stripes here, then you will find it difficult in walking. That is because there is a frictional drag which is not letting you walk. So this is your F cos theta, F sin theta. I hope I was able to make myself clear. So this is the basis ABCD of physics, and where trigonometry, F cos theta and F sin theta, the component, the vertical component of the force and the horizontal component of the force, they get applied, and you split them. You can split them in any direction, but we apply that with reference to what we know and what we don't know, with reference to the force which we know. So vertically we know one force is mgh, right, which is, so when you are walking, these two balance out. But if you jump, there is a chance you may not fly. You'll get a, if you jump vertically, you won't move, you won't have any horizontal component. Why? Because F cos 90, you will, when you F cos 90 is 0, F into 0 equals 0. So that is the reason when you jump like this, you won't have anything. You will not jump upwards, because you'll feel the force. You'll get hurt on the boots, because that much force you are getting from Newton's third law, from the ground to you. Since you are applying that force mgh onto the earth, you are getting that much force. But if you jump on, you have seen babies playing on the balloon where everything is surrounded, and they jump, and they jump above. So there, but they don't move sidewise, right? Because F cos 90 is 0, F0 is 0. So that's for today. We'll have similar discussions going forward. Thank you so much for watching the video. Please do like, share and subscribe. Please subscribe, I would say. That helps me motivate, gives me a lot of motivation, and makes me feel that I should make more videos. Thanks students for watching the video. Have a nice day.